Over the years, mankind has in fact experienced a very significant growth that has continued to transform life as we have always known it. For the generations before, technology, as we know it now, isn't what it was for them. And that just proves the point of how much the world has evolved into what we have today, the information age. With about half the percentage of the people in the world connected to the internet, we now have a race that is more entwined than we've ever known. However, we can't help asking the question, how did we get to this point, and what led to this tool? Welcome back to Prometheus Network. In this video, we will be looking at the invention that made the development of this smartly equipped generation possible, the history of the traditional computer, and how it worked. Make sure to stick around till the end of the video. Now, unlike what we know computers to be today, it was traditionally used to describe machines used to implement calculations using numbers. It started off with the abacus, a computational tool that was used for hundreds of years and was even considered the first calculator, which was simply a manual counting device. Later in the 19th century, the very first programmable and mechanical computer was actualized by Charles Babbage. This design, on the other hand, made use of punch cards to put in instructions for the machine to carry out. However, this ended up being very complex to produce, and so was later cancelled. Basically, what made all these computers stand out was their ability to properly represent numbers and efficiently manipulate them. After this came the further development of analog computers. They were a hit in the 20th century as they provided the function of solving complex mathematical problems. And thanks to World War II, computer technology leaped further a great deal as the nations involved in the war were after gaining the upper hand in the fight. However, later in 1944, Howard Aiken created the very first large-scale computer at Harvard University. This machine turned out to be one of the very first machines to make use of electrical switches for storing numbers. It stored zeros when the switches were turned off and stored the number 1 when it was on. In this same period was the rise of vacuum tubes, which, unlike the relay switches, provided a much faster execution. These vacuum tubes were basically huge evacuated glass bulbs. They were triode vacuum tubes that were made up of 3 different parts: the cathode, the grid, and the anode. The very first general-purpose electronic computer in the world was the ENIAC, which made use of about 18,000 vacuum tubes to execute calculations. This computer was designed by John Mauchly and J. Presper Eckert, but wasn't entirely completed till 1945. However, while this was pretty fast, or rather faster than anything they had ever known, the computer weighed an insane 30 tons and was as big as a whole room. The ENIAC was indeed an insane power-hungry computer, considering how much heat the vacuum tube cathodes needed just so it could function efficiently. All of these processes were necessary for functions that your smartphone would need to run its simplest games. In other cases, it used about 500 vacuum tubes for the generation of radio power to send out human voices over the Atlantic for the very first time in history. There was also the entrance of radio broadcasting with the use of vacuum tubes, and at the time, this showed status. Then the world welcomed talking motion pictures, television demonstrations, and ship-to-shore telephony. This was the entirety of the electronic age, from the coaxial cables to the cathode ray, the iconoscope, and then the image orthicon, all supported by about 100 different vacuum tubes birthed the television, radar for peace, radar for war, and the microwave radio relay to speed up telephone calls, and also television programs. With all of these functions, it expressly meant that the vacuum tubes got completely burnt out regularly. Hence, there was a need for replacements. Aside from that, it consumed as much electricity as was needed to run about 20 homes daily. But in time, the Bell Telephone Laboratories saw the need to add a completely different and new touch to communication systems, and this led to what was later called transistors. The transistors came with a brand new operation principle. All of the computing power that the vacuum tubes possessed was able to be contained on a simple and small silicon chip. The modern phone is made up of about 2 billion of these transistors that perform the exact same functions that vacuum tubes were created to perform in the early times on the nanoscale. Now the question is, how does it work? Many times, when you hear the word transistors, your first thought goes to the through-hole transistor that could be easily purchased at an electronics store for basic personal projects. But on the other hand, transistors embedded in CPUs are much more microscopic transistors that are produced with strained precision. This manufacturing process is done with the machine on thin wafers of silicon crystal, which are sliced off silicon ingots. The reason for the use of silicon is the fact that silicon is a semiconductor, and as a semiconductor, its conducting properties can be modified by simply introducing what is referred to as impurities to the crystal structure. Once these impurities are introduced to the pure silicon crystal, it is quite easy to change its conductivity to a current. With an increase in the number of mobile charges, there is a clear increase in the conductivity of the material. This semiconductor was used in place of the original electrodes that functioned in the vacuum tubes. To create the world's most extensive transistor, the NPN transistor, all that will be required is that the electron-emitting N-type and the electron-absorbing P-type semiconductors are arranged and terminals are attached. But these transistors work as a result of the interactivity between the free electrons and what are referred to as holes at the N-type and P-type junctions. The free electron in the N-type then goes ahead to fill up the holes in the P-type, and soon a boundary layer called the depletion layer is created. The depletion layer is created to stop more electrons from passing through it, considering the negative charges that tend to repel each other. But on the contrary, in the case where a positive voltage is applied to the base, it immediately negates the depletion layer and freely allows current to flow through, hence the circuit is complete. With all of this, you can clearly see how similar this is to how vacuum tubes functioned. But once again, unlike vacuum tubes, transistors played a huge part in allowing computers to perform much more complex functions. That on its own can be quite complex, so let's break it down while we try to go further in explaining the binary system, which was the way numbers were represented. As we already know, binary basically involves ones and zeros, which are used in storing data. Instead of representing numbers as they actually were, electronic computers represented by electric voltages, and most of these computers used a type of math called Boolean logic. The Boolean logic is represented by the values true and false only, and these are denoted by the binary digits 1 and 0, which in essence are high and low voltages. When you have the numbers 1, 1, 1, you know that it is the number 7. The first bit gives you 1, the next represents 2, and the last 4. All of these add up to equal 7, with each successive bit representing double the previous was. This pattern continues. Now to modify a binary code, it makes use of the half adder, which is made up of 2 different logic gates, which are built using transistors. The first of these logic gates is the XOR logic gate that gives a 1 when only one of the inputs is 1, but if both are 0 or just 1 you get a 0. On the other hand, there is the second logic gate, which is the AND gate that gives a 0 in all cases, except when both of the inputs are 1. Once you have these logic gates that are wired like this, a half adder has been created, and this already gives 2 outputs, which are the sum and the carry. That said, if you enjoyed this video and will love more content like this, don't forget to leave a like on the video and let us know what you think about the predictions from more in the comment section below. Also, make sure to stick around by hitting that subscribe button if you haven't done that already, and ring that bell notification so you never miss an update. And we will see you in the next video. Thank you very much for watching.